8.1, number 3. Find the limit as x goes to 0 from the right. So it's a one-side limit. How does that impact it? It may or may not impact it, but like if I had 1 over x here, if I plugged in 0 from the right, that's the same as like 0.00001. 1 over 0.00001 is infinity, you know, as x gets closer and closer to 0. So it'd be 1 plus infinity, which is infinity to this 0. So I get infinity to the 0. Infinity to 0 is indeterminate. If this was 0 from the left, that would be like plugging in negative 0.00001. 1 divided by negative 0.00001 would be negative infinity. So I'd have negative infinity to the 0. So whether it's positive infinity or negative infinity, in this case it's positive infinity, either way it's in indeterminate form. So the right-hand limit here may or may not impact us. I don't think that it does in this problem, but that's how the plus differs from the minus. Okay, so I have a base with it in terms of x and an exponent in terms of x. So the first thing we're going to do is take the natural log of it, but I have to remember to do e to the power or whatever I get with my limit here. Bring down the x, so it's x natural log of 1 plus 1 over x, and L'Hopital's requires us to write it as a fraction, so I'm going to move the bottom, x to the bottom. X to the bottom is the same as moving 1 over x to the bottom. That's the same as x on top. And we're sending x to 0 from the right. Okay, if I plug in 0, I get infinity plus 1. The natural log of infinity is infinity. And 1 over 0, positive from the right, is infinity. So infinity over infinity is indeterminate, so we can go ahead and apply L'Hopital's. So L'Hopital's, if it's in the indeterminate form and it's written as a fraction, you do the derivative of the top and the derivative of the bottom. You don't do them together with a chain rule, you just do the derivative of the top. Times the derivative of the inside, which is negative 1 over x squared, all over the derivative of the bottom, which is negative 1 over x squared. Well, those divide off, so now I have 1 over 1 plus 1 over x as x approaches 0 from the right. So I get 1 over 1 plus infinity, or 1 over infinity, which is 0. Any constant over infinity is just 0. But the first thing we did was do the natural log, so now we have to do e to the power of whatever we get. So e to the 0, which is 1, would be our answer.